All right, today, guys, we're going to learn to rationalize exponents. So we're going to take exponents that are written like this, that something's having the root taken of it, and it's taken to some power. We're going to turn it into a fractional exponent, and then we're going to take fractional exponents and undo them and make them look like this. So to begin with, it says we're going to write each expression in exponential form. So here are some notes that you need to understand. That when you have the square root symbol, the number that's understood to be the root is 2. Because when we square something, we take it to the second power. When we take the square root, we're undoing the second power. We also need to understand that whatever power we're taking it to is going to go in the numerator. And then we have to understand that whatever root we're taking, the root becomes the denominator. So let's look at this example. Well, I know I'm going to need something in parentheses, and I know I'm going to have a fraction for the exponent. So I've just got to decide what goes where. Whatever is underneath your root is what goes in parentheses. So 7p is under your root, so 7p goes in your parentheses. Over here we said whatever power we're taking it to becomes the numerator. Well, we're taking it to the third power, so 3 becomes the numerator. We said the root becomes the denominator. Well, here's the root. It's a square root. And remember, we discussed that that's a 2. We're taking a square root. So a 2 goes in the denominator. And we can, if we clean this up a little bit, we can put an equal sign here in between these expressions because we've just created an equivalent expression. We're still doing the same thing. This means to take the third root, take it to the third power, and take the square root. Like this is saying take the square root, take it to the third power. They are equivalent expressions. It's just different ways of writing it. So let's move on to another example. So now I'm taking the cube root of 6x and raising it to the second power. So I'm going to create an equivalent expression. So I'm going to put an equal sign. I know I'm going to have to put something in parentheses. And I know I'm going to take it to a fractional power because I see a root and I see a power. So the numerator is the power that we're taking it to. Well, we're taking it to the second power. So I'm going to put a 2 in my numerator. So I've used that up. The root becomes the denominator. Well, I'm taking the cube root of something, so that's going to move over here to the denominator. So that uses that up. And so what am I left with? 6x. 6x was under the root. So that's what I'm taking the root of and squaring. So that's what goes in the parentheses. And if I have a way of checking that, for any variable, I can just simply pick any number I want and substitute it in. A lot of people want to use a 1, but 1 works out. So let's pick either like a 2 or a 3, something small, but that's not 1. So what I would do is I would pick 2, and I would substitute it in for x. So what I'm saying is everywhere I have an x, I'm going to put a 2. That's why we work on substitution in that last module, is this is a way of checking our answer. And so when I type these in my calculator, I should get the same decimal. So let's switch over here to Desmos Graphing Calculator. I've got them typed in. The cube root of 6 times 2 squared is 5.214, and so on. And 6 times 2 taken to the 2/3 power is 5.2414, so on. So when it's a short problem like this, substitution is a very, very easy way to check my answer, to make sure that I'm getting a good grade, that I'm practicing correctly, so that when I do it on the test, I know that I'm doing it correctly. So let's erase this one and try one more like this together. So if I have the cube root of 4r raised to the fourth power, to create an equivalent expression in exponential form, I know I'm going to have something in parentheses raised to a fraction. Again, whatever's under the root is what goes in parentheses. So in this case, it was 4r. So I've used up the 4r. Whatever power I'm taking it to, whatever exponent I have, is going to become the numerator. Well, I'm taking it to the fourth power, so 4 becomes my numerator. And then the root becomes my denominator. Well, I'm taking it to the third root, so that becomes my denominator in my fractional exponent. And I've used up all the parts, and I've created an equivalent expression. And I can check that in my calculator if I need to. So now we're going to take those same rules and we're going to apply them in reverse. So what happens when I'm given an exponential expression and told to write it in radical form? Well, we still have to remember that if it has a 2 on the bottom, we use the square root symbol for the root without the 2 in it. And that whatever number is in the numerator becomes the power, and whatever numbers in the denominator becomes the root. So here we go. I know that I'm going to have parentheses. I know I'm going to have parentheses. I know I'm going to have to take the root of something because I see a fraction in the exponent. I know I'm going to have to raise it to some power. So what am I having to take the root of and then take it to a power? Well, it's what was in parentheses. So 5x is in parentheses, so it has to go under my root. My power is what the numerator was. So this says I'm taking it to the 7th power. My root is whatever the number the denominator was. This is saying I'm taking the 4th root. So I have to put a little 4 in there. So now I have created an equivalent expression. So let's walk through another one a little bit slower, and then we'll check it in our calculator to make sure we're doing it correctly. So I see something taken to a fractional exponent, and I know I have to write it in radical form. So I'm going to create equivalent expression so I can put an equal sign. So I know I'm going to have to take some type of root and take it to some type of power. That's why I have to put it in parentheses. Well, what am I taking the root and the power of? Well, it's whatever was already in parentheses. And in this case, it was 2x. So I've used up the 2x. I won't use it again. Whatever number's in the numerator of my fraction becomes my power on the outside of my parentheses. In this case, my numerator is a 5. So I'm taking something to the 5th power. And then my root is my denominator. Well, I have a 2 in my root. So if it makes me feel better, I can put a little 2 in there to know that I've used it. But when I go to type it in, I don't type a 2 in. I leave it as a square root because we talked about that earlier. It's understood to be in there. So let's pick a value and substitute in here and make sure we have indeed created equivalent expressions. So let's substitute in a 2. So if I do 2 times 2 and I raise it to the 5/2 powers, I should get the same answer as if I do the square root of 2 times 2 raised to the 5th power. So let's switch over to a calculator, clear it out here, and it's parentheses 2, and when I substitute in, I like to use parentheses so that I know it's 2 times 2 versus 22, and I want to raise that to the 5/2 powers, and that's telling me it's equal to 32. So if I do the square root of 2 times 2, and I raise that to the 5th power, I also got 32. So my answer is correct. I simplified well, I didn't simplify. I turned my radical form into, I turned my exponential form, into radical form correctly. So that is what you're going to practice the rest of today.